So we're going to do math modeling with quadratics. We're going to be using standard form in order to see how they apply in the real world. And if you take out your packet that goes along with this, then you will see this exact problem. So you have a note sheet that is for 8.4 and 8.5. Instead of using your workbook, we're just going to do the notes right here. A company offers a rectangular pool sizes with dimensions as shown. Each pool includes a deck around it. If Caroline wants a 15-foot wide pool with a deck, how many square feet will she need to have available in her yard? Okay, so let's just look at what they're talking about here. So we're saying that we have a 15-foot wide pool with a deck. So one of the first things we need to look at is what is this distance right here? Okay, so we know that this distance is 4 feet. Well, if that's 4 feet, then this is also 4 feet. See how it goes 4 feet all the way around? So that means I have my distance of 2x plus 4 plus 4. So this is going to be 2x plus 8. And then we know that this right here is 4, and this right here is 4. So if I talk about this being x, then I'm going to have that this side is x plus 8, because 4 plus 4 is 8. Now we're going to write a quadratic function to represent the area of the pool and the deck. So we don't have to take it out. It's different than what we did before. We're not finding out how big the patio is around or how the deck is. We're finding out the two of them combined. So all we're going to do is take area, remember, is length times width. So my length is 2x plus 8. My width is 8x plus 8. So area is equal to 2x plus 8 and x plus 8. Okay, that's our quadratic equation. Now we can multiply that out if we want to. So to find the quadratic function f of x, or a of x for area, we're just going to multiply this out. So remember 2x times x and 2x times 8, 8 times x and 8 times 8. Good. So a of x, the area, is 2x squared plus 24x plus 64. Now it says it wants us to find the area of the pool and the deck. So what we have to use is that we know that the width of the pool, okay, she wants a 15-foot wide pool. So this right here is 15 feet wide. So all we're going to do is find the area at 15. So if I plug 15 in for x, so I'm going to take 2 times 15 squared plus 24 times 15. Pull out your calculators. Here we go. So we're going to come up with 874 square feet is what Caroline is going to need. Carolina is going to need in her yard. So that's how many square feet we're going to need in order to build a pool and a deck. So this just shows one way that you can use quadratic functions to answer questions. So the next one is one of it. Usually this is at the end of all of your notes, and I just put it up here. So you'll notice the numbers are kind of weird when you look at your worksheet. So a rectangular patio has a length 4 times its width. It also has a 3-foot wide brick border around it. Write a quadratic function to determine the area of the patio and the border. So all it wants us to do is find the quadratic function. We don't even have to find the area this time because it doesn't give us enough. So the first thing you want to do is draw a picture. So on this one, the first thing we want to do is we want to draw a picture. Now, what we have to understand is that we have a rectangular patio. This is our rectangular patio, and it has a length 4 times its width. And notice the last thing we compare to, that's going to be our variable. Okay, and this is 4 times that. Then we have a brick border that goes around it. So there's a patio, and then for decoration, probably they put a brick border around it. Now what it's saying is that this distance here is 3 feet. Okay, so it's a brick border that's 3 feet around. So then what we have to look at is that if this is 3 feet on this side, it's also 3 on this side. So my length is 4x plus 3, which is 6. And then my width also has a distance of 3 here and a distance of 3 here. So this is x plus 3, which is x plus 6. And now to find the quadratic function of the area, and you can use f of x, you can use lots of things. I'm just saying a for area. I'm going to take 4x plus 6 times x plus 6. And you're going to multiply that out, and then you're done. So multiply, go, it's good practice. So you would have found out that the area is 4x squared plus 30x plus 36. Good. And that's all you're really always going to do is multiply length times width. So keep that in mind. This is length times width, and look what you come up with. Pay attention to that, because you're going to have a problem someplace. I don't know where I read it, if it was in this homework or in the quiz or test, where they give you the entire area and then they want a length and a width. So in other words, you have to take the area and factor it. Okay, keep that in mind. So the next thing we're going to take care of is what's called vertical motion model. And the equation for the vertical motion model is this right here. So you're going to want to write that down. This is the model for vertical motion. And when we talk about vertical motion, we're talking about throwing a ball up in the air or dropping something off into a well, or lots of different things. Now let me explain what these two things mean right here. This right here, v sub 0, that, and notice it says here, v sub 0 is the initial velocity. Okay? And it's v for velocity and 0 for a subscript, because it's saying it's the initial, it's the starting point. And you can guess right here that h is the height, and the 0, the subscript, so h sub 0 is the initial height. So we're going to have an initial velocity and an initial height, and we're going to be using those different ways. So make sure you have this written down. And for Algebra 1, we are not going to have you memorize this. This is a formula that you will use over and over and over again, not only in Algebra 2, but also in physics. Probably will show up in calculus lots of times. So this is one that you'll see lots. So for Algebra 1, we're going to give this to you every time, but you do need to know what V sub O stands for and H sub O. Okay, H sub 0, not O, V sub 0 and H sub 0. Sorry about that. So, on our next problem, a diver jumps off of a platform at an initial vertical velocity of 16 feet per second. And the reason this is in this is because look at this picture. Come over here. Look at this picture. Look at this shape right here. You should recognize that. That's a quadratic. That's a parabola. Now, we don't go down through here, but we're saying from if I start up here, and anytime you throw something in the air, it goes up and then it comes down. And it will always form a vertical quadratic. So this is vertical motion. So keep that in mind. And that's the model of it. So we're going to be using that f of x or a of x or whatever you want to call it is equal to negative 16 t squared, so that's time, plus v sub 0 t plus h sub 0 t. So we're going to be using that. So now we're going to take this model and we're going to plug it in for this picture. So we have f of x is equal to negative 16 t squared plus, what is our initial velocity? Our initial velocity is 16. Plus, what is our initial height? Okay, where do we start? Well, we start 30 feet above the ground. So this is our function. Negative 16t squared plus 16t plus 30. Then it says, how many feet above the platform will the diver be at the highest point? So look at what your highest point is. Your highest point, what do you notice that is? Hopefully you're all saying, it's the vertex, Mrs. Phipps. That's right. This right here happens to be the vertex. Okay, the vertex is going to tell us the y-coordinate of vertex is the maximum. This is y-coordinate. The y-coordinate of the vertex is going to be the maximum here. It's also going to be our greatest height. And that's usually what they use here is h. I'm so sorry, that's usually an h. So that's going to be our height. Our maximum is going to be the highest point. Okay? Our height is that's going to be our highest point. So that means we have to know what the y-coordinate is in order to find it out. So what we're going to have to do is find the vertex of this. Remember what we're going to use to find the vertex. The x-coordinate of the vertex is going to be negative b over 2a. So we're going to plug that in. So we get negative b over 2a. So we get negative 16 over negative 32, which is equal to 1/2. That's the x-coordinate of the vertex. And I'll tell you more about what that means in just a second. Now, if we want to find the y-coordinate, remember what we do? We just plug it into the function. So we're going to find h of 1/2. That will give us the y-coordinate. So we go negative, so this would be t. Wow, I'm just messing up all over the place. Okay, so sorry about that. So now we're going to have negative 16 times 1/2 squared, and if you want to, make that 0.5 plus 16 times 1/2 plus 30. So this is negative 16 times 1/4. Oh, this is kind of fun to do without a calculator. 16 times 1/2 is 8 plus 30. So 6/4 of 16 is negative 4. Now you could have just plugged this into your calculator, I know, but it's kind of fun. So that's 34. So what's our initial what's our highest point? Our highest point is going to be equal to 34 feet because it's the y-coordinate of our vertex. So our vertex is 1/2 and it's 34. Okay? Now what does that 1/2 mean? That 1/2 means time. We're talking about the time here. See how we plugged it in for t? So what was the time? Well, look back up here, we're feet per second. So this is going to be 1/2 second, and we're going to be at 34 feet. So sometimes they'll ask us, how much time did it take? That's going to be the x-coordinate of your vertex. When they ask us the height, that's going to be the y-coordinate of your vertex. Okay, notice that axis of symmetry goes right through here. Okay, and that's going to be hitting at 1/2, your time. So if this were on a graph, this would be time down here, and this would be height over here, okay, or feet. Good. So for this, they want us to find the maximum height, okay? We want to find the maximum height above the water, so this point right up here. Find the maximum height above the water. And what they tell us, it is a 20 foot, so yep, this is 20 this time, and our initial velocity is 8. So what I'd like you to do right now is, of course, your function is h of t is equal to negative 16t squared. That negative 16 has to do with acceleration due to gravity, is where it comes from. You'll learn more about that. V sub 0 t plus h sub 0. Okay, so plug in what you know, go. So hopefully you know that this is my initial height, and this is my initial velocity. So your equation would be negative 16t squared plus 8t plus 20. That would be my function, but it wants the maximum height. So to find the maximum height, I'm going to have to find the y-coordinate of the vertex. That's going to be my maximum height. Notice maximum. So when we talked about finding the maximum, that's going to be your y-coordinate. So what we have to do is we have to find the vertex. To find the vertex, okay, the x-coordinate of the vertex is going to be equal to negative b over 2a. So let's plug everything into that. So that's going to be negative 8 over 2 times negative 16. Negative 8 over negative 32 is going to be positive 1/4. That is the x-coordinate of our vertex. And if they would ask about at what time did he hit its highest, we would say 1/4 second. Now we're going to find the y-coordinate of the vertex by plugging it into our formula. So we're going to find h of 1/4. And that's what's so great about function notation, is it's so easy to see what you're actually plugging in, and it helps you remember what your x-coordinate is. Why did I draw a line? I do not know. Let's try this again. Okay? So we're going to go with negative 16 times 1/4 squared plus 8 times 1/4 plus 20. Go. So hopefully you came up with 21 feet. That's going to be his highest point, or their highest point. is 21 feet. When did it happen? At 1/4 seconds. So your vertex tells you everything. Your y-coordinate is your maximum, and your x-coordinate is your time. Good. Hope that's making sense. If so, physics will be lots easier when you take it. Now, you don't have this in your notes, but I just wanted to point it out to you. The question in this, the essential question, what kinds of real-world situations can be modeled by quadratic functions? Area and vertical motion problems can be multiplied. So area, okay, because you would have distances around. And then vertical motion, that's where it's going to go up and come back down. So it's going to be a parabola. The shape would be a parabola. If you throw a ball up in the air, it has to come back down. Okay? What does it mean in a real-world situation when the initial velocity is 0? So your initial velocity is 0 in your formula, negative 16t squared plus v sub 0t plus h sub 0. When our initial velocity is 0, that means there was no force. We did not project it. We did not throw it. We just dropped it. So the object is dropped. That's if my initial velocity is 0. Good. So now we're going to go through and find 5 and 6 are going to be using the information we were just talking about. Write a vertical motion model in this form, okay, for each situation. So all we have to do to begin with is know where to plug it in. So h of t is equal to negative 16t squared plus what? That's right, your initial velocity. So that'd be 32t plus, of course, then 20. That would be my function, but I'm going to make you also find the maximum height. So the maximum height means that we have to find the vertex. And we actually have to find the y-coordinate of the vertex. That's going to be the y-coordinate of the vertex. Okay? So we first have to find the x-coordinate of the vertex. And in order to find the x-coordinate of the vertex, we have to use negative v over 2a. Go. So did you find out the x-coordinate was 1? That's right. So my vertex, therefore, is going to be 1. Now we're going to, and that's how long it would take to hit the maximum height. So now we're going to find the height by plugging it in. So we have negative 16 times 1 squared plus 32 times 1 plus 20. So negative 16 plus 32 plus 20. That's 16. So I got 36. So 36 feet would be my maximum height. Good. Okay, I want you to try number 16. Number 6, do this one right here all on your own, and then we'll come back and compare. Go. So you can see that we're just plugging in 120 because that's our initial velocity. That's our v sub 0. And this is our h sub 0. Good. Now go and find the maximum height. Follow what we just did in number 5. So we found our x-coordinate is 3.75. Yes? Go find the y-coordinate. Find that maximum height. Go. So we plugged in our x-coordinate of vertex in for h of 3.75. We plugged that all in. Came up with 725 square feet. Feet, not square feet. That's area. Okay, so hopefully you know how to write the function, and you also know how to find the maximum height. That's what we're looking for. So on this last slide, I just wanted to look at a couple things that we're going to be doing on this one. And you'll notice this should look familiar. Yep, I took that right out of your homework. So this is one that I thought we should at least talk about. For each vertical motion model, identify the maximum height reached. So they want the maximum height. We've been doing that. And they want the amount of time. So your maximum height is going to be the y-coordinate of your vertex. And the amount of time is going to be the x-coordinate of your vertex. If you haven't already figured that out, a vertex. And I'm just giving you those notes so when you get to homework, it won't be so confusing. Okay? Then this other one, if the area of the rectangle, so this is where area equals 3n squared minus 7n minus 6. It wants you to find the length and the width. And I've already talked about this in this video, but just wanted to make sure. So I have a quadratic function. If I want to find the two factors that give me that, I'm just going to factor this. So you're going to multiply 3 times negative 6. Put a negative 7 down here and go. Find the factors of negative 18. Hopefully you remember how to do this. If not, ask your teacher. Great. Okay, that is all of 8.4. Please go and do the assignment that is posted on Schoology now. If you have any questions, you know where to find us.